Assalamualaikum and hi everyone. Topic 10, Application of Differentiation, Lecture 2 of 3, Part 3 of 6. At the end of the lesson, students should be able to A. Solve optimization problems.
Example 3. A rectangle is to be inscribed in a semicircle of radius 2. What is the largest area the rectangle can have and what are its dimensions? Okay, so the information given here is there is a rectangle to be inscribed in a semicircle of radius 2. To help you to answer the question, the equation of the semicircle is given here. The diagram is also given here. So, I want you to consider the point here. Let the point here be P, the coordinate is x, y. Okay, x means the length here is x and y is the height of the rectangle. If the coordinate here is P, x, what is the value for y here? Okay, y in terms of x can be written as set of 4 minus x squared. Okay, the radius of the circle is 2. Okay, now what is the question asked here? The question asks what is the largest area of the rectangle can have and what are the dimensions? Okay, so what is the function to be maximized here? Okay, I want you to ask yourself, what is the function to be maximized here? The function to be maximized here is area. Okay, the largest here means maximum. So we want to find out what is the maximum area. I will use area as A. Okay, so what is the maximum area and what is the dimension? Means the value for x and the value for y. Okay, the question asks to find the largest or the maximum area, means you have to write area A as a subject in terms of x. Okay, why? Because we want to find the maximum area. The function to be maximized here, you need to let as a subject. Okay, therefore you have to imagine the area of the rectangle. The length is 2x and the height is given as set 4 minus x squared. Okay, so the area of the circle of the rectangle can be written as 2x multiplied with set 4 minus x squared. Then you need to differentiate A with respect to x to get the maximum area. Therefore, dA dx is equals to, I will use product rule here, where 2x I will let as a u and set 4 minus x squared I will let as v. So copy paste u, 2x, what is v prime? V prime is equals to set can be written as 1 over 2 4 minus x squared to the power of negative 1 over 2. Then you need to differentiate 4 minus negative x squared. The answer is negative 2x. U v prime plus v. What is v? Set of 4 minus x squared. and u prime differentiate to x. The answer is 2. Okay, now we simplify by cancel out 2 there. Okay, so you simplify, you will get negative. We have negative here, negative 2x times x. We have negative 2x squared over 4 minus x squared. Negative 1 over 2 are bring down to be 1 over 2 plus 2 third 4 minus x squared. Okay, then you have to know that for this function x cannot equals to 2. Okay, x cannot equals to 2. To get the maximum area, dA dx must equals to 0. Okay, so dA dx must equals to 0 to get the maximum area. Okay, therefore we simplify to get negative 2x squared over third 4 minus x squared plus 2 third 4 minus x squared is equals to 0. Then we simplify 2x squared over third 4 minus x squared is equals to 2 third 4 minus x squared. Then you cross multiply, you will get, here is over 1, so you will get 2x squared is equals to 2 third times third, you will get 4 minus x squared only. So 4 minus x squared. Then simplify to get 2x squared minus 8 minus 2x squared. Then you will have 4x squared equals to 8. X squared equals to 8 over 4. That is 2. X equals to plus and minus 2. Okay, so remember that x is the length, the dimension, so cannot take the negative value. So we only choose x equals to 2 because x must more than 0. Okay. Okay, now I will write again what is the first derivative dA dx. dA dx is equals to negative 2x squared over 4 minus x squared to the power of 1 over 2 plus 2 times 4 minus x squared. Then I will simplify to equalize the denominator, and you will get the denominator as 4 minus x squared to the power of 1 over 2. Then we have negative 2x squared plus 2 times z, you will have 4 minus x squared. Then we will simplify to get negative 4x squared plus 8 over 4 minus x squared to the power of 1 over 2. Okay, then this is dA dx. Remember, to show that the area of the rectangle is maximum, you need to do the second derivative. Okay, and you have to substitute the value of x into the second derivative, and you have to show that the second derivative after you substitute the value of x equals to cert2 must be negative value. Okay, therefore we have to do the second derivative now. To get the second derivative, we will use quotient rule here, where I will let u as the numerator and v as a denominator here. So u is equals to negative 4x squared plus 8. U prime is equals to negative 8x. V is equals to 4 minus x squared to the power of 1 over 2. So V prime is equals to 1 over 2 multiplied with 4 minus x squared to the power of half minus 1, negative half, and you have to differentiate the inside function, that is negative 2x. And then 2 is cancelled out by 2, and the answer is equals to negative x multiplied with 4 minus x squared to the power of negative 1 over 2. Okay, now we will cross the formula here. Therefore, d squared a dx squared, the second derivative of dA dx, is equals to vu prime. So v, you have to multiply with u prime. V u prime minus u v prime over v squared. V is 4 minus x squared to the power of half. You have multiplied with u prime, negative 8x, minus u multiplied with v prime. U is negative 4x squared plus 8. You have multiplied with v prime, that is negative x multiplied with 4 minus x squared to the power of negative 1 over 2. And we have to close the bracket. Don't forget to divide by v squared, that is 4 minus x squared. Okay, then simplify. We will simplify by factorize the same terms here, that is both term here we have x, means we can factorize x. I put negative in front, then we both term also have 4 minus x squared to the power of negative 1 over 2. I will factorize the smallest factor. So the remaining term here is 8 multiply with 4 minus x squared. 4 minus x squared to the power of 1 actually. So if you multiply again with 4 minus x squared to the power of negative half, you will get back this term, that is 4 minus x squared to the power of half, because half minus 1 over 2 equals to half. And for this term, you need to multiply with negative of negative 4 x squared plus 8, and don't forget to divide by 4 minus x squared. 4 minus x squared. Then we will simplify to get d squared a dx squared is equals to negative x. In the bracket we have 32 minus 8x squared plus 4x squared minus 8 over 4 minus x squared to the power of 3 over 2. Okay, I combine the factor of 4 minus x squared, collect together to be the denominator here, and simplify to get negative x multiply with negative 4x squared plus 24 over 4 minus x squared to the power of 3 over 2. Or we expand, we will get 4x cubed minus 24x over 4 minus x squared to the power of 3 over 2. 3 over 2. Okay, so this is the second derivative of a with respect to x. After we get second derivative, we will substitute x, the critical value that we have, that is x equals to sec2 into d squared a dx squared, and we want to show that after we substitute x equals to sec2, the answer is negative value to get the maximum area. Okay, now we will substitute d squared a dx squared, and you substitute x equal to sec2, you will get 4 multiply with sec2 cube minus 24 multiply with sec2 over 4 minus sec2 squared, sec2 squared, and power of 3 over 2. Then simplify, you will get sec2 times sec2 times sec2 is 2 sec2. We get 8 sec2 minus 24 sec2 over 2 to the power of 3 over 2. 8 minus 24 sec2, the answer is negative 16 over 2, or you can write as negative 8, that is less than 0. Okay, negative 8 is something negative less than 0. Therefore, we can say that d squared a dx squared, the value is equals to negative 8, that is less than 0. Therefore, the area is a is maximum. Okay, so we need to find what is the maximum value of a. Therefore, the value of a is a equals to 2 sec2 multiply with, the area is 2x to 2 sec2 multiply with cert 4 minus 2. Close the bracket, and the answer is 2 cert 2 times cert 2 is equals to cert 2 times cert 2 is 2. 2 times 2 is 4. Okay, so 4 unit squared. This is the maximum area. Therefore, we can conclude that d squared a dx squared is equals to negative 8, that is less than 0. Therefore, the area is maximum. So our conclusion is the maximum area of rectangle is 4 unit, and the dimension when x equals to cert 2. Okay, now I want to share with you the summary on how to solve the optimization problems. Okay, so the first step you need to do here is for our previous example, you need to find out what is area in terms of function x, in terms of x. Area is a subject here because we want to find out the maximum area. Area is A, okay? Area to be maximum here. And secondly, you need to find out what is the first derivative dA dx. And you need to equal to 0 to get the area maximum. Then when you solve, you will get x equals to plus and minus cert 2. Okay, I only choose cert 2 here. So when x equals to cert 2, the area is maximum, but you need to do until second derivative, that is d squared a dx squared. Then you have to substitute x equals to cert 2 into d squared a dx squared, and show that you will get the answer is negative, that is less than 0. Okay, which is mean that area A is maximum. Okay, so our conclusion is when you get the second derivative is negative here, so the conclusion is the area is maximum when x equals to cert 2. Okay, that's all I want to share with you. You have to proceed until the second derivative here. Okay, you cannot stop only at first derivative. Okay, please proceed until second derivative and show that you will get the second derivative is negative. Thank you.